Hello everyone, as I promised in the previous lesson, we're going to solve a few integral problems. So starting with this question, I'll be sharing a few problems that are all about integrals. That's because students usually struggle a lot with this topic. I'm hoping that with the way I explain it, you'll be able to understand. Alright, here's the question. In the Cartesian coordinate plane, the graphs of the functions f of x equals x squared minus 2x and g of x equals minus x squared plus 4x, along with the shaded region between them and the x-axis, are given on the side. According to this, what is the area of the shaded region? Now, sometimes students ask me, how do you know this is an integral question? I mean, the question doesn't even mention the word integral, right? And to be polite, I say, you're right. But of course, when we talk about area under a curve, we're talking about integrals. Sure, integrals aren't only used to find areas. They're also used in physics, engineering, even economics. But just to keep it simple, you can think of integrals as a way of calculating area. In this question, we're asked to find the yellow area under the curve. First, we need to find the points where these two functions intersect. To do that, we set the curves equal to each other. X squared minus 2x equals minus x squared plus 4x. Solving this equation, we find two roots, 0 and 3. 0 is pretty obvious, so let's mark 3 as well. Now, between 2 and 3, let's shade the area under the curve x squared minus 2x in blue. We'll find the total area of both the yellow and blue regions using an integral. Since this region lies under the curve minus x squared plus 4x, we'll integrate that function from 0 to 3. This gives us the total area of the yellow and blue regions combined. Let's compute the integral. The antiderivative is x cubed over 3 plus 4x squared over 2. If you plug in the lower limit x equals 0, it gives 0. If you plug in the upper limit x equals 3, you get 9. So now we know the total area is 9 square units. Next, we subtract the blue area from the total to get the yellow area. To find the blue area, we integrate the curve x squared minus 2x from 2 to 3. The antiderivative is x cubed over 3 minus x squared. If you plug in the upper limit, x equals 3, you get 9 minus 9 equals 0. If you plug in the lower limit, x equals 2, you get 8 over 3 minus 4 equals 4 over 3. So the blue area is 4 over 3, and the total area was 9. That means the yellow area is 9 minus 4 over 3, which is 23 over 3. That's it. Wasn't too bad, right? We'll keep going with integrals for a while, so stay tuned. See you in the next lesson.